Welcome my dear students. My name is Gurinder Pal Singh. Hope you are fit and fine. This is my third video lecture on surface chemistry. In this video we will study about colloids. So students, a colloid is a substance microscopically dispersed throughout another substance. The word colloid comes from a Greek word kolla, which means glue. Thus colloidal particles are glue-like substances. These particles pass through a filter paper but not through semi-permeable membrane. If I'll talk about phases of colloids and their classification, then students, we know that colloidal solution is of heterogeneous nature. It consists of two phases, a dispersed phase and a dispersion medium. Students, a dispersed phase is a component present in small proportion and is just like a solute in a solution. For example, in the colloidal solution of silver in water, the former act as dispersed phase. Former means silver. Silver is the dispersed phase. And if I'll talk about dispersion medium, it is generally component present in excess and is just like a solvent in a solution. Considering the same example, in the solution of silver in water, water acts as a dispersion medium. On the basis of size of particles of solute, solutions have been classified into three types: true solution, colloidal solution and suspensions. So first of all, we will discuss about true solutions. Students, true solution is a homogeneous solution which contains small solute particles dispersed throughout a solvent. For example, the solution of sodium chloride in water. The particle size is less than 1 nanometer. And the particles of a solute in a true solution are invisible even under microscope. Next, we will study about suspension. Suspension is a heterogeneous mixture which contains small insoluble particles. Students, particle size is more than 1000 nanometer. For example, dust particles in water. The particles of suspension may not be visible to naked eye but are visible under microscope. Third one is colloidal solution. Students, colloidal solution is a heterogeneous solution which contains particles of intermediate size. For example, milk. Particles of a colloidal solution have diameters between 1 to 1000 nanometer. Such particles cannot be normally seen with the naked eye. Let's study the comparison of three types of solutions. Well, in true solutions, particle type can be ions, atoms or small molecules, and in colloid, particle type can be large molecules or particles, and in suspension, particle type can be large particles or aggregates. In true solution, particle size is less than 1 nanometer. In colloid, particle size is from 1 nanometer to 1000 nanometer, and in suspension, particle size is greater than 1000 nanometer. Students, true solutions do not show Tyndall effect and colloid solutions exhibits Tyndall effect and suspension also exhibits Tyndall effect. Students, let me explain you the meaning of Tyndall effect. Tyndall effect is a scattering of light when it is passed through a solution. It will be discussed in detail in the next videos. If I'll talk about effect of gravity, then true solutions are stable and we cannot separate. In the similar manner, colloid solutions are also stable and also we cannot separate. But suspension are unstable and sediments will form. In true solution and colloidal solution, particles can pass through ordinary filter paper. It means particles will not retain on the filter. But in suspension, particles cannot pass through ordinary filter paper. It means particles will retain on the filter. Now, if I'll talk about the uniformity of true solution, colloid or suspension, then true solutions are homogeneous, colloidal solutions are heterogeneous, and suspension are also heterogeneous. Students, examples of colloids are milk, synthetic polymers, fog, blood, jam, shoe polish, smoke, etc. Now we will do the classification of colloids. Colloids are classified on the basis of physical state of dispersed phase and dispersion medium, nature of interactions between dispersed phase and dispersion medium, type of particles of the dispersed phase, appearance of colloids, and electric charge on dispersion phase. Now we will study the first classification, which is on the basis of physical state of dispersed phase and dispersion medium. Students, depending upon the physical state of dispersed phase and dispersion medium, whether these are solids, liquids or gases, 8 types of colloidal systems are possible. Like solid sol, aerosol, gel, emulsion, aerosol, solid sol and foam. Now students, it is clear from this table that many common commercial products and natural objects are colloids. For example, whipped cream is a colloidal system. Whipped cream is a foam, a gas dispersed in a liquid. Students, depending upon the nature of interactions between dispersed phase and dispersion medium, the colloidal solutions can be classified into 2 types as lyophilic colloids and lyophobic colloids. In lyophilic colloids, colloidal solution in which the dispersed phase has a great affinity for the dispersion medium is called lyophilic colloids. Lyophilic colloids are generally self-stabilized, they are reversible in nature. Examples of lyophilic colloids are starch, gelatin, rubber, etc. But in lyophobic colloids, colloidal solutions in which the dispersed phase has no affinity to the dispersion medium. They are relatively unstable and also irreversible by nature. For example, soles of metals like gold, silver. Now we will discuss the comparison of lyophilic and lyophobic colloids. Students, lyophilic colloids are prepared by direct mixing with dispersion medium, but lyophobic colloids are not prepared by direct mixing with the medium. In lyophilic colloids, there is little or no charge on particles, but in lyophobic colloids, particles carry positive or negative charge. In lyophilic colloids, particles generally solvated. Students, solvation is an interaction of solute with the solvent, which leads to stabilization of the solute species in the solution. In lyophobic colloids, there is no solvation of particles. In lyophilic colloids, viscosity higher than dispersion medium and they set to a gel. But in lyophobic colloids, viscosity is almost the same as of medium and they do not set to a gel. Students, lyophilic colloids are precipitated by high concentration of electrolytes, but lyophobic colloids are precipitated by low concentration of electrolytes. Lyophilic colloids are reversible, whereas lyophobic colloids are irreversible. Lyophilic colloids do not exhibit Tyndall effect, whereas lyophobic colloids exhibit Tyndall effect. Last but not the least difference is lyophilic colloid particles migrate to anode or cathode or not at all. On the other hand, particles of lyophobic colloids migrate to either anode or cathode. Depending upon the type of particles of dispersed phase, colloids are classified as multimolecular colloids, macromolecular colloids, and associated colloids. In multimolecular colloids, on dissolution, a large number of atoms or small molecules of a substance aggregate together to form species having size in colloidal range, means diameter is less than 1 nanometer. For example, gold sol, sulfur sol. And students, in macromolecular colloids, they are formed when macromolecules added in suitable solvent for solution in which the size of macromolecules in the colloidal range. Such colloids are quite stable and resembles true solution in many respects. For example, starch, cellulose, proteins and enzymes are natural macromolecular colloids, but polythene, nylon, polystyrene, synthetic rubber, etc. are man-made colloids. And next is associated colloids, also called micelles, the substances which when dissolved in a medium at low concentration behave as normal strong electrolyte, but at high concentration exhibit colloidal behavior due to the formation of aggregates. Students, the aggregate particles is called micelle, and the concentration above which micelles can be formed called critical micelles concentration (CMC), and the temperature above which micelles can be formed called Kraft temperature. For example, synthetic detergent and soaps. CMC for soaps is 10 to the power minus 4 to 10 to the power minus 3 mole per liter. Now students, I will tell you the condition for micelles formation. Actually, the condition is substances which contains polar head and non-polar tail form micelles. Now we will study the mechanism of micelles formation. Students, when soap dissolves in water, it dissociates into RCOO negative and Na positive ions. And students, RCOO negative ion consists of two parts. First is non-polar part R, which is called tail and which is water repelling. And second one is polar part, that is COO negative and called head, which is water loving. So students, the RCOO negative ion present on the surface with their COO negative groups in water and R group staying away from water. But at CMC, anions are pulled into the bulk of solution and aggregate to form a spherical shape with their hydrocarbons chain pointing towards center of the sphere with COO negative part remaining outward on the surface of the sphere. And students, an aggregate thus formed called anionic micelles. These micelles may contain as many as 100 such ions. Students, this is the arrangement of stearate ions on the surface of water at low concentrations of soap. And this is the arrangement of stearate ions inside the bulk of water, that is ionic micelle, at critical micelle concentrations of the soap. Now we will study the cleansing action of soaps. So my dear students, the cleansing action of soap is due to the fact that soap molecules form micelle around the oil droplet in such a way that hydrophobic part of stearate ions is in the oil droplet and hydrophilic part projects out of the grease droplet like the bristles. And we know that since the polar groups can interact with water and the oil droplet surrounded by stearate ions is now pulled in water and removed from the dirty surface. Thus, soap helps in emulsification and washing away of oils and fats. And one more thing, that the negatively charged sheath around the globules prevent them from coming together and forming aggregates. In figure A, there is a grease on cloth. In figure B, stearate ions arranging around the grease droplet. And in figure C, grease droplets surrounded by stearate ions, means micelle formed. Now let's do the comparison of multimolecular, macromolecular and associated colloids. Students, as we know that multimolecular colloids are formed by aggregation of large number of atoms or molecules with diameters less than 1 nanometer, whereas macromolecular colloids are formed by large sized molecules and associated colloids are formed by aggregation of large number of ions in concentrated solution. Multimolecular colloids are lyophilic in nature, macromolecular colloids are lyophobic in nature, whereas associated colloids are both lyophilic as well as lyophobic in nature. Molecular mass of multimolecular colloid is intermediate, whereas macromolecular and associated colloids have high molecular mass. Multimolecular colloids are held by weak van der Waals forces and macromolecular colloids are held by strong van der Waals forces due to long chains. And in associated colloids, van der Waals forces increase with increase in concentration. Now if I'll talk about based on appearance of colloids, it is of two types, sols and gels. First I'll talk about sols. When a colloidal solution appears as a fluid, the sols are generally named as dispersion medium. When the dispersion medium is water, and sol is known as hydrosol or aquasol. When the dispersion medium is alcohol or benzene, it is called alkosol and benzosol respectively. Whereas in gels, colloidal solution appears as solid. The rigidity of gel varies from substance to substance. For example, jelly, butter, cheese, curd, etc. Next classification is based on electrical charge on dispersion phase. It is of two types, positive colloids and negative colloids. In positive colloids, when dispersed phase in a colloidal solution carries a positive charge, for example, metal hydroxides like FeOH3, aluminium hydroxide, methylene blue sol, etc. And in negative colloids, when dispersed phase in a colloidal solution carries a negative charge, for example, silver sol, copper sol, etc. Now we will study the general methods of preparation of sols. Lyophobic sols can be prepared by mainly two types of methods. First is condensation method, second is dispersion methods. In condensation methods, we can prepare sol by chemical reactions, by excessive cooling, by exchange of solvent, or by change of physical state. By chemical reactions, there is oxidation, in which a colloidal sol of sulfur is obtained by bubbling H2S gas through the solution of bromine water, sulfur dioxide, nitric acid, etc. In reduction, the colloidal solutions of metals are obtained by reduction of their compounds. In hydrolysis, a colloidal solution of ferric hydroxide is prepared when a concentrated solution of ferric chloride is added drop-wise to hot water. Now next, by excessive cooling, a colloidal solution of ice in an organic solvent like ether or chloroform can be prepared by freezing a solution of water in the solvent. The molecules of water, which can no longer be held in solution, separately combine to form particles of colloidal size. By exchange of solvent, colloidal solution of certain substances such as sulfur, phosphorus, which are soluble in alcohol but insoluble in water, can be prepared by pouring their alcoholic solution in excess of water. For example, alcoholic solution of sulfur on pouring into water gives milky colloidal solution of sulfur. In dispersion method, we can use mechanical dispersion and electrical dispersion. In mechanical dispersion, the substance is first ground to coarse particles. It is then mixed with the dispersion medium to get a suspension, and the suspension is then grinded in a colloidal mill. It consists of two metallic discs nearly touching each other and rotating in opposite directions at a very high speed, about 7,000 revolutions per minute. In electrical dispersion or Bradig's arc method, this method is used to prepare sols of metals such as platinum, silver, copper or gold. Students, the metal whose sol is to be prepared is made as two electrodes immersed in dispersion medium such as water. The dispersion medium is kept cooled by surrounding it with a freezing mixture. An electric arc is struck between the electrodes, and the tremendous heat generated by the arc vaporizes the metals, which are condensed immediately in the liquid to give colloidal solution. The colloidal solution prepared is stabilized by adding a small amount of potassium hydroxide to it. Next one is baptization. Students, what is baptization? It is a process of converting a freshly prepared precipitate into colloidal form by the addition of a suitable electrolyte, which is called baptization. The electrolytes used for this purpose are called baptizing agents. Now students, what is the cause of baptization? Well students, when an electrolyte is added to a freshly prepared precipitate, the suitable ions from the added electrolyte are adsorbed by particles of the precipitate. Now, the charged particles repel one another and form colloidal solution. For example, treating a precipitate of ferric hydroxide with a small amount of FeCl3 solution gives a reddish brown colored colloidal solution. Students, in this case, Fe3 positive ions from ferric chloride are adsorbed by FeOH3 precipitate. Now, we will study the purification of colloidal solutions. First one is dialysis. Students, the process of separating the particles of colloid from those of crystalloid by means of diffusion through a suitable membrane is called dialysis. Its principle is that colloidal particles cannot pass through a cellophane membrane while the ions of electrolyte can pass through it. One more thing, the impurities slowly diffused out of the bag, leaving behind pure colloidal solution. Students, dialysis can be used for removing HCl from ferric hydroxide salt. As the ordinary process of dialysis is slow, so to increase the process of purification, dialysis is carried out by applying electric field. So this process is called electrodialysis. Artificial kidney machine make use of electrodialysis. Next one is ultrafiltration. It is a process of high pressure filtration through semi-permeable membrane in which colloidal particles are retained while small sized solute and solvent are forced to move across the membrane by hydrostatic pressure forces. In simple language, we can say it's a process of removing the impurities from colloidal solution by passing it through graded filter papers. My dear students, ultrafiltration is a vital process that takes place in the kidneys. Now students, these are some questions related to the topic. You can easily complete these questions. Hope you enjoyed this session very much. Thank you so much students and goodbye.